Alright, so my name's Sam, I'm a third year PhD student at UCL. We're going to go back and talk about thermal performance and measuring thermal performance. My talk is entitled Understanding Uncertainty and Applying the Coating Method. The coating method is a way of measuring total building heat loss. What's important is understanding the intrinsic uncertainty in this measurement, and indeed any measurement. So what's really nice about coating is it measures heat loss across an entire fabric. And if you saw Sophie's image earlier showing the variation across the floor, we can see there's lots of variation across the fabric. So by measuring across the entire fabric, we pick up on this variation, pick up on any defects in the fabric. We also measure unexpected heat loss mechanisms or more complex heat loss mechanisms, which we're perhaps not predicting in our models. So it's a really useful feedback tool and quality assurance tool. However, really with this measurement, we need to understand a few things. And these are things such as comparability. So can we compare the results between two tests? Is it fair to compare them? Reliability. Is this measurement always reliable? Is it reliable in any weather conditions or just in a certain set of conditions? And also we need to hold of what is the accuracy of this test measurement and what is the uncertainty of it. So I'm going to show you some examples. The first question I've asked is, can I compare between results? In the first case, top row of histograms, we're going to look at the same building, the exact same building, but just tested in a variety of weather conditions. And if the test measurement wasn't susceptible to any sensitivity due to weather conditions, then we'd all have just one point. We'd always measure the same thing. You can see, if we take this top left example, there's a spread, there's a range of data, ranging from the low 40s to the mid 70s. That's quite a range of measurements, and that's just in weather between October and March, so the winter sort of heating season. But there's still a big range. So can we compare results between tests when we expect such a different range in different weather conditions? And the problem is if we're just doing one test, we're going to be somewhere in that distribution, but we don't know what that distribution looks like, and we don't actually know if we're underestimating or overestimating. So really what's important is to understand how different weather conditions might drive you to either underestimate or overestimate your measurement. And you can see if we look at different locations, this distribution changes as we go down to sunny and warm climates or cold and northern climates. And then the second thing we'll look at is, what if we have the exact same conditions, the exact same weather conditions, but we're testing different types of buildings. And what I'm showing you here is a lightweight and a heavyweight building, which are identical in every single way, other than the fact that one's lightweight and one's heavyweight. And we can see the distribution of results, the measured heat loss. The lightweight building is quite a tight distribution, quite small and narrow. And that's not the same with the heavyweight building. So if we were testing the heavyweight and the lightweight building right next to each other under the same weather conditions, well, we might expect a nice reliable result for our lightweight building. We might actually be getting an underestimate for our heavyweight building, which means it's very difficult to compare the two with any sort of fairness at all. The final question to do with these issues of comparability is, can I measure the benefit of a retrofit intervention? Two people came to the poster asking about retrofit interventions, and they're interested in measuring this sort of thing. And what I've shown you is two sort of before and after. So the baseline case of the black points of each graph is a heat loss of 247, and then we're seeing two reductions when we've measured the heat loss again. Now one of these, the one on the left, is actually a retrofit intervention, so it's changing from single to double glazing. And it's measured under the exact same conditions, so we can quite reliably say that we think the reduction is about 29 watts per Kelvin. On this side, we're seeing an even bigger reduction, this time of 66 watts per Kelvin. But actually, we're not testing a different building, it's the same building twice. It's a single glazing building twice, but under different weather conditions. And you can see how this sensitivity to different weather conditions on the measurement can sort of mask what your potential benefit is, either from a retrofit. Also, it can exaggerate it. We might think our retrofit measures far more successful than it actually is. So we really need to understand what's driving the uncertainty in either direction before we can successfully compare any measurements and then begin to use them as a feedback tool. Okay, thank you very much.